All right, so we're gonna do a 3.4 partial fractions, and also we call the partial fraction decomposition. All right, so before we do that, we integrate one over u du, then we know that ln absolute value of u plus c, right? And we have integration of du over u squared plus a squared. That is 1 over a arctangent u over a plus c, right? Okay, now before we're going to into the techniques, so one of this section techniques called partial fraction or partial fraction decomposition. Okay, so it's like the same concept with the earlier sections. We cannot use up, right? Then we try to do other things. There is no other things in 3.1. So we had IBP, which is integration by part, right? Then 3.2, we could not do U sub, we could not do IBP. Then we were using trig sub, right? I mean, trigonometry integration, right? Then 3.3, we cannot do U sub, we cannot do IBP, we cannot do trig integration. Then we are using trigonometry substitution. Now look at this one. I mean, this one we can. All right, so I'm asking you right now. I'm talking too much. So how do we integrate this one? We cannot integrate this one?
Or do we integrate each part separately, like 1 over x plus 1, and then we integrate 2 over x plus 2 separately?
All right, so what do we have then?
I don't know.
I was showing you this, which one?
Maybe the arctan one. I don't know.
No, this is a ln x plus 1. Okay, the first one. Also, second one is 2 ln x minus 2. You take the u sub, let u equal to x plus 1. What's dx? What's dx? What's du? Which is dx, right? Then this is ln x plus 1. And second one as well. Do you agree? Yes or no?
Yes.
Okay. Then arctangent, in order to use the arctangent, we have to have x squared, right? We don't have that, correct? And then we have to have addition as well too, right? But then look, if we make common denominator, this one, before that, we can express this one How about common denominator first? Common denominator. How about there? Common denominator. Then we get x plus 1, x minus 2. Then we get half. We're going to have 1 times x minus 2. First term, second term has x plus 1, right? Then this will be x plus 1, x minus 2. Then x minus 2. Plus 2. Trying to rush this way. X minus 2 plus 2x plus 2, right? Then let's see. So 2 is 0, and we get 3x over x plus 1, x minus 2, right? All right. So in this case, if we have a question like that, question. If we have a question 3x over x plus 1, x minus 2, or 3x over, let us distribute this one, then we get x squared minus x minus 2. Okay, denominator. So this is basically same. Okay, either one, if we have this one, or if we have this one, there's no way we can find integration. All right? Then look, this is actually come from this one, right? So this one actually same as this one as well. Then if we call this as a partial fraction decomposition. So if we using this technique, then we can integrate. So we can find integration of the functions. Make sense? So this is the section main idea, all right? Okay, so before we do that, they give us some tips. So the tips say that if we have P over X over Q over X and uppercase Q over X. All right, we are using partial fraction decomposition. So we decompose with a fraction like that from the 3x, okay? Then only the numerator is, the degree of numerator is less than degree of denominator. Then what if the degree of numerator is greater than degree of the denominator? Does anyone has idea? Partial fraction decomposition. All right, so degree of numerator is greater than degree of the denominator, then like algebra, we're using polynomial long division. Okay, so let us do polynomial long division first. Then we are using partial fraction decomposition because polynomial long division method we learned from the algebra and pre-calculus, right? Okay, so let us do this. Find integral of x squared plus 3x plus 5 over x plus 1 dx. All right, so we have a p over x, numerator, q over x, denominator. We talk about the degree. So numerator has bigger, right?
Yeah.
Then denominator. Okay, then we are using polynomial long division. How? So like this. So divisor x plus 1, dividend, which is x squared plus 3x plus 5. All right. Back to the algebra, right? So x squared over x, what do you get? X. Then we times, then we get x squared plus, and second term has x. Now, Your professor always say that, oh, parentheses and subtraction, right? In order to get rid of first term, we make a parentheses and then subtract, all right? Now, first term is 0, second term has 2x, and we bring down the further one. Plus 5. Now we think 2x over x, what do you get?
Just 2.
Just a 2, thank you. So with the plus 2, then we multiply first term, which is 2x, and we multiply second term, which is the plus 2. Then we subtract, then we get 3 as a remainder, right? So this is a remainder. We could, this is a quotient. So how do you write this one? So we write this this one like this, right? So quotient plus the remainder or divisor. Okay, so look, we have the integration. Then this is the same as quotient, which is x plus 2, then plus the remainder and dx. Okay, now looks like there is too much parentheses, but we can do one by one, right? So like a term by term, so we can do that. If you want x dx plus 2 so integrate, what do you get? The first term. First term?
X squared over 2.
Excellent. Second term?
2x plus 2x
Excellent. Third term?
plus 3 ln x plus 1.
Excellent. 3 ln x plus 1,
1.
absolute value. Very good.
Same.
Plus C. Okay, that's how we do. All right. So in this case, the degree of numerator was greater than degree of the denominator, right? Now, let us focus on partial fraction decomposition technique. Okay, so we are learning that. Okay, so here, every time we have a strategy and tips. So non-repeated linear factors. I want to say partial fractions decomposition technique. All right, so look, we're gonna have this kind of a form. Look, we have P over X over Q over X. Now, this will be, we denote like S sub 1, which is constant. And we have A sub A, X plus B sub 1. Just notation, okay, the form. So if we see this kind of a form, then we call non-repeated linear factors. Okay, so let me show you how it looks like So find 3x plus 2, x cubed minus x squared minus 2x dx. Okay, so partial fraction decomposition technique, we are using this one for the degree of numerator. I have to say degree, huh? Is less than degree of the denominator, right? All right, so we checked that, right? So in this problem, degree of numerator is less than degree of the denominator, right? 2 degrees less. Okay, now can you please factor out denominator? This one?
Factor out.
Oh, we can factor. We
X
can
to the
factor out.
fourth
an X.
divided by.
Oh,
So factor out.
are we gonna factor out an X?
Good. So
And
x
X-
squared minus x minus 2, right? Very good. Now, can you factor more?
S minus 2, S plus 1.
Very good. Okay. So now we factored, right? So can you see that everything is linear, right? This is a linear, also this is a linear, also this is a linear. And then they said that non-repeated. There is nothing repeated, right? So by itself, linear, each of them, right? So this one we can express, okay? Look, I'm climb up.
partial fraction.
So look, we have 1 and 2 of this integration, right? Because we said this is the same as, right? This is the same as that, this is the same as that, right? Look, if we find these numbers, those numbers, then those numbers is equal to this number, so that we can integrate more easily, right? Can you see that? And then looking at the bottom two, bottom has the, which is denominator, it's a linear, right? So let's take a look. So in this case, we're gonna find A, B, C, because we have 3 different linear. So this is equal to, look, right? So equal to, we're gonna say A, constant. They say constant. They say another constant, and so on, right? So since we have 3, we're gonna say that we don't want A sub 1, A sub 2, A sub 3. It's a little bit confusing, right? So we're gonna do A, B, C, all right? So A over X plus X minus 2 plus X plus 1. So we say that B, C. Can you see that? We have a linear in the denominator. We're gonna say constant, which is ABC. So basically, we have a first degree C. In this case, we make a constant, which is 1 degree less than the denominator. You notice that? Okay. All right. Now, how they find the ABC then? Okay. Lot of algebra work. Okay. So in this case, look. We want to make equal to. Now I want to do algebra, the right side, make a common denominator. Okay, CD means common denominator. So that is X minus 2, X plus 1, right? Then first fraction need A x minus 2, x plus 1. Second fraction need b x, x plus 1, right? Then third one has need c x and x plus 1, right? Yeah, x plus 2. Please correct me if I make a mistake. All right. Now we say that this fraction equal to this fraction, right? Since the denominator is exactly same as this denominator, right? So we can say that only numerator equal to numerator. So we have a 3x plus 2 equal to, I will just copy down numerator, okay? So a x minus 2, x plus 1, plus bx, x plus 1, plus cx, x minus 2, okay? Now, I will show you the method. Book indicate the method of strategic substitution, okay? So all right, means that think. Get rid of term by setting x value. All right, so for example, let x equal to 0. So let me up. So looking at this one, now we're gonna find what is the constant, which is ABC, right? And one of the method, we have a method of strategic substitution, and second method, which is method of equating coefficient, which is the system of equation. So let me show you system of equation later on the problem. So to this section, I mean this problem, let us do this. All right. So look, let x equal to 0. So I say that get rid of the term by setting x value, right? So I want to setting this x value is 0, then third term will be 0, right? Can you see that? So look, then 3x equal to 2, so it's a 2. A 0 minus 2, 0 plus 1. Can you please calculate?
And I think B and C is gonna cancel. I mean, it's gonna
B also 0, yeah. B also 0, right? So
in C also.
this is 0 plus C is also 0. Let me just denote it this way, right? So everything is 0 except first term is there, right? So we have 2 equal to negative
Okay, 2a.
yeah, 2 equal to, sorry about that.
A equals -1.
Negative 2a.
5 equal, oh, no.
A equals -1.
A equal to -1?
Yes.
Yes. Yeah. You said okay. I'm just kidding. All right. So second one, let x equal to 2. Then look, if we set it on x equal to 2 there, right? Then this will be 0. Can you see that? Also, if we have a 2 there, then this will be 0, right? So let us using that. 3 times 2 plus 2 equal to A equal to 0 plus B 2, 2 plus 1 plus C equal to 0, right? C is 0. Then we have Can you please calculate the left side?
It's 8.
A.
8 equal to
6.
6b. Good. So b equal to what?
2.
4 divided.
Oh, good. 4 over 3, right? Good. Now, third one. So look where it go. We are using 0. We are using 2. What is the leftover here?
1.
-1.
Oh, very good. X equal to -1, right? So
Negative.
let X equal to -1. Okay, 3. You please you calculate 3 -1 plus 2 equal to A equal to 0 plus B equal to 0, right? And plus C -1 minus 2. Okay, left side, what do you have?
Negative 1.
-1 equal to everything is 0. What about C? -3 positive is 3C.
3C.
So hard. So positive C, I mean positive 3C.
3C.
So C equal to -1/3, right? Okay, good job. Whew. A lot of hard work going on. Okay, then integration is easy. All right. So integration, we are using either one. Look. Either this or that. Okay. So integration is easy, but algebraic, finding the numerator constant or sometimes a linear later on is hard. I mean, a lot of work. Okay. I want to write down this one. Look. Okay, so ABC. Okay, so A, we had A equal to -1. Let me write down. A equal to -1, B equal to 4 over 3, C equal to -1/3, right? So we're gonna have -1 x. Let us make it term by term. Plus B, which is a 4/3. And C equal to -1/3. All right, can you integrate? What do you have? The first term.
In S.
Good.
Minus
LMS?
logarithm.
Yeah. Okay, second term. Finally, yes.
4/3 ln x minus
Everything is
2
ln, right? Can you see that? Good. X minus 2. There is no
minus
special one. Good.
1/3 ln x plus 1.
Plus C. Okay. This is how we do in this section. The techniques. Partial fraction decomposition. So we make a decomposition of the fraction. All right. Okay. Then let us do repeated linear factors. So numerator has non-repeated, which is x, x minus 2, x plus 1, right? But in this case, repeated. So let me write down repeated linear factors. So this form has like this. We have s of 1, which is constant, And then linear, which is ax plus b. Now, second term, constant. And repeat. So we're gonna repeat ax plus b, quantity squared. Okay, now, third, repeat. So we're gonna repeat this one to the third, okay? And so on. And we will have a sub n over ax plus b to the fourth power. I'm sorry, not fourth, to the n power. Okay, now how do we do that? This number 3. X minus 2 over 2x minus 1 to the squared, x minus 1 dx. Okay, looking at the denominator, already linear form, isn't it? Okay, and we check the degree. So degree of numerator is less than degree of denominator, right? So then we can use partial fraction decomposition. So look, this one, how we write, look, this one is squared. Can you see that if we have a squared, in this case, we can make a linear itself. So look, this one, we're gonna express it this way. So x minus 2 over 2x minus 1. And we're gonna make, hold on. I want to make just a straight forward, like a ABC, all right? So I don't want to rewrite. This will be A linear plus repeated linear, then squared plus and linear again, x minus 1, okay? And since the denominator has a linear, so we're gonna make 1 degree less, which is constant term. So A, B, C in this case as well, okay? Now, in this case, we're gonna use the, what is called, they have a little bit longer name, method of equating coefficient, which is we did in algebra course, thus using eliminated the system of equation. It's the same as, right? So let us do this one. Okay, common denominator. Which is, look, when you have common denominator, this and that, right? Right? So we have 2x minus 1 squared, x minus 1, that is common denominator. Common denominator. Then A need, the first term need, the one more 2x minus 1, then times x minus 1, right? And second term need x minus 1 and plus, then third term. So when I taught the pre-algebra a long time ago, I said, oh, what this gentleman need? And C need 2x minus 1 quantity squared, right? Okay, look, I skipped one step. because it's the same, right? So we have this one equal to that. So they are identically same denominator. So we can just set it up x minus 2 and that, okay? So we are using this one. X minus 2 equal to maybe different colors, so we notice it later on. X minus 2 equal to, let me just rewrite right side. Plus c 2x minus 1 quantity square. Okay, look. We're gonna multiply everything. So 2ax minus a, oh, a lot of work. Not the little bit better one. Okay, what can I do? I cannot do anything. Let us multiply this one first, everything. Okay, then multiply a. So we have 2x squared, a 2x squared.
Minus 2x minus x plus 1.
So minus 2x, and then negative x, which is negative 3x.
Yes.
And there. Okay, good. And then last term, which is
Plus
positive 1.
a.
Okay, plus a, good. Very good. Thank you so much for help. Plus bx minus b plus, oh, this one too. We have a squared minus 2ab plus b squared, right? So a squared, which is 4x squared, and we have a c there. And minus 2 times a times b, which is 2, is 4, and 4cx plus b squared, which is c, right? Please correct me if I make a mistake. All right, then let us combine to like x squared. So look, x squared there, right? So we have 2a plus 4c x squared, and x term x, x. So minus 3a. Okay, let us make a positive, so make a negative there, and plus b, and minus 4c x. And constant term has a plus a minus b plus c. Okay. All right. So looking at this one, can you see that x squared? There is no corresponding, right? X squared is 0. Can you see that? So we will write down since I use blue letters, so 2a plus 4c equal to 0. Now x term, this one x, which is corresponding with this one. Since there is one invisible one, we say the one there. So negative 3a plus b minus 4c equal to 1. So I want to rearrange this one. 4c, that's correct. Okay, the last constant term, a minus b plus c. Look, the constant term corresponding -2. So we will have a minus b plus c equal to -2. All right? Okay, now we're gonna use, what's the name of the, what's the name of, so they say the method of equating coefficient. Long name. But in algebra, we say that this is eliminating. That is correct. The system of equations or solving system of equations, right? Same thing, solving. Okay. All right. So let us using that. This will be, which one is the easiest one? Number one, equation number one, equation number two, equation number three. So we say that C, this is 0. Then C equal to, how much we get? So we add everything up, right? So everything up. So 1 minus the -2, which is, thank you, Sia. Oops. Oh my God. Accidentally. Please forgive me. Okay. So we add, so this is 0. And then 1 minus 2, which is -1, right? It's equal to -1. Thank you. All right. So we have a c equal to -1. Then look, equation number 1, right? Substitute equation number 1. So we have a 2a plus a 4c equal to 0. 2a plus 4, -1 equal to 0. What's the a?
2.
2, thank you.
Oh,
Now the last one, equation number 3. So we have a substitute.
I might be wrong. Is it actually 2?
Is it 2? Yes, it's 2. Okay.
Okay, yeah.
Yeah. Be confident. Be confident. Be
After
confident.
so much information, I start to.
Yeah, it's okay. Thank you. All right. So equation number 3, we have a minus b plus c equal to -2. So a equal to 2, b, we want to look for c was the -1. Now, what's the b? We are done. Integration is easy.
Maybe 3.
B equal to 3. Good. All right. Now, the question. Let me rewrite this one. Copy. Okay, so we had a equal to 2, b equal to 3, c equal to -1, right? So we're gonna find the integration. So A, which is 2. So we can write down this way. B, which is 3. C, which is -1. All right. We know that this is ln, this is ln, right? How about this? Any idea? No one can think? Okay, how about no one has idea? Okay, how about let u equal to u sub 2x minus 1 with derivative, what do you get?
2ds.
2dx, good. We don't have a 2, so we divide by 2 both sides. So we have 1/2 du equal to dx. Look, then we have, oops, 3 there, 1/2 there, and integrate dx will be du over, okay, since we're gonna use power, so let us write down u to the -2, right? Okay, power, what do you get?
It's just 1 over u, right? Or 1 over negative 1 over u.
Negative?
Yeah, well, yeah,
Negative 1? Okay,
u to the -1.
yeah, good. So we will have -3/2. U was 2x minus 1. Since 1 in the denominator, we get that, right? X, 2x minus 1. Parentheses. Okay, so we're gonna write down this is the answer. Okay. So you guys okay with this? All right, let's move on. Getting advanced. So we have the quadratic factors. So we have quadratic factors. So in the quadratic factors, we have irreducible. Okay, so we have irreducible. Means that we cannot factor out, right? Okay, we cannot try out every single numbers, right? Then how do we know this is irreducible? Then we check if the b squared minus 4ac is less than 0, like inside the square root from the quadratic formula, we have that kind of form, right? So what's the ABC? Quadratic form, quadratic here looks like this, ax squared plus bx plus c, okay? B squared minus 4ac less than 0, then we say that irreducible. Irreducible means we cannot factor out. All right, so let us do this one. What number is this one? 4. Okay, so find 2x minus 3 x cubed plus x. Okay, we check that degree of a numerator is less than degree of the denominator. So we can use the technique which is partial fraction decomposition. Okay, this is a fraction. All right. Then how do you factor out the denominator? Can you please do that?
Oh, you can factor out an x, so it's just x squared plus 1.
Yeah.
X first, good. So we get the x squared plus 1, right? But then we know that x squared plus 1 is irreducible, which is cannot factor out, right? So
Sure.
look that, look, we're gonna make the form of decomposition, okay? So look, normally we have A, normally we have a B. When this one happens, when the denominator has the linear, right? But then look, this is the linear. So yes, this is good. But then this is not linear because this is a quadratic. Can you see that? If a quadratic, look, we had all the time, the denominator has linear, right? In this case, linear with repeating, right? So if we have a linear, then we just constant. So 1 degree less than the degree of the denominator, right? So quadratic, what is the 1 degree we can express, which is the linear. Make sense? So we're gonna express this one. 1 degree less, which is linear, which is, okay. Your book indicate the ax plus b, so I want to follow your book because it's a lot of algebra. So I want to know if we make a mistake, we can fix right away, okay? So let me do this. So we're gonna have a linear form like a cx, in this case, the cx plus d, that's the linear form, but I want to follow the book. So your book has this one first. So we're gonna use ax plus b as a linear, and denominator has x squared plus 1, the quadratic, and plus c over x. So denominator is linear, so we are using constant term, okay? Now, same concept. The denominator has identically same, okay? Oh, we have to make a common denominator, right? So we forgot that. Common denominator. So we have x squared plus 1 So this lady need X, right? So we're gonna have X. And this may need X squared plus 1. Okay. This one, which one will be better? System of equation is better. Okay, so we say the numerator equal to same as the right side of the numerator. So we have two x minus 3 equal to, so we have, I am just writing down first, and distribute. Okay, now we do ax squared plus bx plus cx squared plus c. Okay, now yeah, let's do system of equation using that technique, the method. All right, so we combined like x squared. So we have a plus c is x squared plus bx plus c. Okay, corresponding. Look, there is no x squared. So x squared corresponding equal to 0. So, and look, bx, x itself equal to 2. And look, c equal to -3. Oh, wow. Then we can find only a, right? So we have c corresponding the constant term, which is -3. All right, then we have equation number 1. So substitute equation number 1. So a plus c equal to 0. A equal to 3, thank you. So we have a equal to 3, b equal to 2, c equal to -3, right? Good. Let's see. Okay. Let me copy down. Please. One more time, try. Come on. Okay, good. Okay, so we have a equal to 3, b equal to 2, c equal to -3. Okay, so here I'm gonna make integrate. So a, which is 3, x plus b, which is b equal to 2, x squared plus 1 and let us do this one. Plus c over x. Did I make a mistake?
No. You say it's -3 the C.
So we're gonna make an integration like that, all right? All right, look. If we're using a sub, or if you're thinking about arctangent, this is not working, right? So we're gonna split term by term here, okay? We have to recognize. So this will be 3x over x squared plus 1. Let's take out the 3 since we split term by term. And 2 out. Okay, so look, either one we integrate ln or arctangent. Which one is ln, which one is arctangent? Looking at the beginning here. So we have this form, which is ln. This form is that. Okay. All right. So what do you get this one? Which one is ln? Either one. First term or second term?
The last one.
Yeah, you said the last one. I heard that. Yes, good. Very good. What about the first one and second one? Which one is ln? Hello. Let's finish. We have one last one, advanced one.
tangent.
First one is arctangent. First one is the ln. Okay. So let u equal to what? X squared plus 1. Derivative, what do you get? With derivative?
2x dx.
2x dx. All right. Okay, then. We don't have a 2, so we divide by 2. So we get 1 over 2 du, which is x dx. Okay. So we will have 3 du u, right? What do you have? This one?
ln.
Good, thank you.
Plus
So
2.
this will be 3 over 2 ln x squared plus 1 plus second term.
Oh, no, plus.
So this is arctangent, right? So 2 arctangent. This is a form of arctangent. So u over a, so x over a, which is x over 1, which is x, right? And minus your classmate said earlier, 3 ln x and plus c. Okay, All right. So let me just finish here. Thank you for coming.